everyone, welcome to my channel Learn with Raiza, and today we are going to learn about the lesson indices. It's grade 7. So in this video you will learn many things about the lesson indices. So please watch this video until the end. Subscribe my channel, like and share. Right. Index notation is used to write a number which is multiplied repeatedly in a concise way. So this statement, let's see it in a very deep manner now. So let's see how to express a power and a base in index notation. So for example, if I take number 9 is equal to 3 to the power 2. This is read as 3 to the power 2. So there, what you have here is the base. This is the base and we call this one as the index. So here what we do is we represent number 9 with a base and an index. So we read this as 9 is equal to 3 to the power 2. So this power 2 means, if I expand it and write down, 9 is equal to 3 to the power 2 means 3 is written twice. 3 times 3 is giving 9. So this is the index and this is the base. Now I'll teach you how to expand a product and how can we find the value of each expression. For example, now the example I'm taking here is 3 to the power 2 multiplied by 2. Right, here I'm going to teach you how to expand as a product. How to expand as a product. So 3 to the power 2 means, I told you, this is the base and this is the index. To the power 2 means you write 3 twice and multiply it by 2. It is only 1. So 3 times 3 is 9. 9 times 2 is equal to 18. So simply I can say that 3 to the power 2 multiplied by 2 is equal to 18. Another example, 2 to the power 3. Read it with me. 2 to the power 3 multiplied by 3 to the power 2. 2 to the power 3 means, listen very carefully, 2 is written thrice because the power is 3. 3 to the power 2 means 3 written twice. Now let's multiply. 2 times 2, 4. 4 times 2, 8. 8 times 3. What is 8 times 3? 24. 24 times 3. You can multiply 24 times 3. You are getting 3 times 4. That is 12. 2 here. Remainder 1 here. 3 times 2, 6. 6 plus 1, 72. So the answer will be 72. So what did we do here? First we expanded the power and we multiplied continuously and got the answer as 72. Right? To make it more clear, I'm going to take another example. Example number 3. 2 to the power 4 multiplied by 3 to the power 2 multiplied by 5. Now you try to do this alone. Pause your video and try to do this alone. And check whether your answer is matching with the answer that I am going to explain. Right. 2 to the power 4 means 2 multiplied by 2 multiplied by 2 and again another 2. Power 4 means 2 is written 4 times. Multiply by 3 to the power 2 means 3 written 2 times. 5 is only single. Now be careful. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3. You know multiplication. 16 times 3. 3 times 6 is 18. 3 times 1, 3. 3 plus 1, 4. 48. 48 times 3. Again multiply continuously. 3 multiplied by 8, 24. 4 here, 2 here. 3 times 4, 12. 12 plus 2, 14. 144 multiplied by 5. So see, you can see that continuously it goes 144 multiplied by 5. 5 times 4, 20. Last digit here, 2 here. 5 times 4, again 20. 20 plus remainder 2, 22. 5 times 1, 5. 5 plus 2, 7. Final answer is equal to 720. See whether you understood, see whether you got your answer. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3, I multiplied and got 48. 48 times 3, I got 144. 144 times 5, I got 720. So this is the way of expanding the powers and getting the final answer. Well, now I'll teach you the other way around. When it is already expanded, how can you write it as powers? For example, this is expanded in the format. So how can we write it as a powers? Powers means with a base and with an index. So if you note this number 2, you can see there are 1, 2, 3, 4. 2 is common. The power will be, since it is arising 4 times, 2 to the power 4. Multiply by 3 arises twice, 3 to the power 2. Another example. Right. 3 is common. So 3 base to the power 3. 1, 2, 3. Multiply 5. So it can be in two different places as well. That's why I took this example. It comes twice. 5 to the power 2. Multiply by 2. This 2 can be written as 2 to the power 1 also. If this is not there even, that's not a problem. So this is the way of writing the expanded numbers as powers of certain bases. So hope it's clear hope that it's clear for you all. So let's move to the next part. Now let's see how to write a given value as a power of a number. So for example, if I tell you write 25 as power of 5. How to write 25 as a power of base 5, let's say. Power of base 5. Base is 5. So you know that the base is 5 means 5 times something should be. 5 times how many 5s we need? How many 5s you need to make 25? Yes, of course it is 2 5s. Because 25 divide by 5, the short method, 25 has how many 5s? That is 5. So 5 times 5 is 25. So I can write 25 is equal to 5 multiplied by 5, which is equal to 5 to the power 2. So you can see that the base is 5, power or the index is 2. So we wrote 25 as a power of base 5. Similarly, if I ask you to write down 64 as a power of base 8, how do you do that? So you know that 64 we can divide in by 8 and see that 64 divided by 8, multiplication table, 8 times 8 is giving 64. So 64 is equal to 8 multiplied by 8, which is equal to base is 8. How many 8s are there? 2. 8 to the power 2. Next is, let's see how to write the same number 64 as a power of base 2. Right. In your previous lesson, unit number 4, factors and multiples, part 2, you are learning how to divide it by prime factors and all. So let's see. 64 will divide by 2 because we want the base 2. Right. Divide by 2. Go with me. 6 divide by 2. What is it? Yes, 3. 4 divided by 2, that is 2. No remainders. 3 divided by 2, 1. 1 remainder, it becomes 12. 12 divided by 2, what is it? 6. Now, 16 divided by 2. 2 times table, what number is giving you 16? Yes, 2 times 8. 8 divided by 2, you divide it in your mind, 2 times table, 8 divided by 2, 4, 4 divided by 2, 2, 2 divided by 2, finally 1. So finally until you reach 1, you have to keep on dividing. So you can notice that the common base is 2. So 64 is equal to 2 to the powers. How many 2's are there? 1, 2, 3, 4, 5, 6. So 2 to the power 6 is giving 64. Let's check our answer and see whether it's correct. How to check? We'll expand 2 to the power 6. 3, 4, 5, 6. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, what is it? 32. 32 times 2. If you want, I'll show you. 32 times 2, you are getting 64. So since we are getting the answer, 2 to the power 6 is the correct format of writing number 64 as a power of base 2. So this is the way of writing a given number as a power of any base they are asking us to do. So let me give you some questions. Try to pause the video and do them and check it yourself. Well, this is the question for you. Write 81 as a power of base 3. So I told you, if you want to select any base, if it is here it's base 3, so divide 81 continuously by number 3 base. Right, start your timing now, pause your video and start doing. Well, 81 divided by 3. In 8, how many 3's are there? Yes, that is 2, because 3 times 2 is 6. So in 8, if you have 2 3's, how many remainders are there? That is 2 remainder. So there you are getting remainder 2, it will become 21. So 21 has how many 3's? In 3 times table, what number is giving you 21? 3 times 7. 27 divided by 3. In 3 times table, what number gives 27? 3 times 9. 9 divided by 3, simply it is 3. 3 divided by 3, you have only 1. So how many 3's are here now? 81 is equal to 3 is our base. How many 3's are there? 4. So the answer will be 3 to the power 4 will give you 81. I'll explain you this again. In 8 you have 2 3's but 2 remainders. So 21 comes. In 21 you have 7 3's. 27 divided by 3, 9. 9 divided by 3, 3. 3 divided by 3, 1. So 81 is equal to 3 to the power 4. Right, now it's time to go to the next part of your lesson, that is how to write down powers with an algebraic symbol. Algebraic symbol will be your base. So that means, for example, base means the bigger number x. X to the power 3. This is the base and this is the index as usual. So only change is, this is nothing new, only change is the base is a letter. Algebraic means a simple letter in your alphabet. So x to the power 3 means just like the one we learned. We learned 2 to the power 3, let's say. I told you 2 times 2 times 2. X to the power 3 is also x times x times x. So this is the difference in algebraic and numerals. So just like the same thing what we learned in numbers, I taught you how to expand powers and I taught you how to write the expanded power in index format. Similarly, I am going to teach you here also. So if you are given a base and an index in algebraic form, for example, y to the power 2 is z to the power 3. So y to the power 2 means y written twice. Z to the power 3 means Z written thrice. This is the expanded form. So, if you are given an expanded algebraic expression, for example, P times Q times P times Q is equal to what? As powers and bases, how do we write down? So, there what you have to do is, P is written twice and here ones. Altogether we have 3 p's, p to the power 3. Q is written twice, so put a multiplication, q to the power 2. So we can write this together as p times q is pq, here to the power 3, here to the power 2. This is the final answer. So what did I teach you here? Powers with algebraic symbol as the base. Algebraic letter is the base, power index is a number. Like in numbers, same way we expand, and like in numbers, the same way we write the powers also, counting how many letters are there of the same base, and we write them as the powers right in the common base, and we can get the final answer. So this is simple, right? And suppose if you are getting something like this, how do we do? Right. Expanding, listen, x multiplied by x multiplied by x, 1, 2, 3, multiply by how many y's? Y into y into y. So suppose if they ask you to short it, like, write it as a common product. You can take x and y together. Both are having powers of 3. Both are having powers of 3. So within brackets you can write and put the power 3 out. That's also fine. Similarly here, q multiply by q multiply by m multiply by m. 2 q's and 2 m's. Shortly you can write down qm to the power 2 because both are powers of 2. So this is the way of doing, powers that have an algebraic letter as the base. Right, now let's see. Suppose if you are asked to find the value of the power with the base of an algebraic letter, right? Let's see how to do that. Right, now go to the lesson now. Finding the value. Finding the value of a power by substitution. Right, what is this substitution? Let me explain you it clearly. Let me take an example. As usual, we'll take x letter, x to the power 3, let's say. Right, x to the power 3. Assume now, you think that x is number 2. This is called substitution. You are substituting the valued number 2 instead of x. I can write this as 2 to the power 3, which is equal to x to the power 3. So I can write down x to the power 3 is equal to 2 to the power 3 equal to 2 multiplied by 2 multiplied by 2, which means x multiplied by x multiplied by x. Same thing. So what did we do? Instead of x we wrote number 2 when we expanded. What do we get here? 2 times 2, 4. 4 times 2, 8. Which means that x to the power 3 is equal to 8. So this is called as substitution of a given value to the base. Let's do more examples. Well, if I tell you, take A is 3 and B is 5. And if I take a base with a squared B to the power 3. This is your question, let's say. How to do this now? Substituting. Instead of A, okay, listen this very carefully. I'll expand first of all. If you listen it very carefully, you will understand. A to the power 2 means A twice. B to the power 3 means B thrice. Instead of A, I am writing number 3. Again 3. But here B means 5. 5, 5, 5. 3 times 3, 9. 5 times 5, 25. And another 5. Now multiply. 9 times 25 will multiply here. 9 times 25. 9 times 5, 45. 5 here, 4 here. 9 times 2, 18. 18 plus 4, 22. Now this what we do here? We multiply this value. 225 we get. Still one value is remaining. We'll multiply it by 5. 5 times 5, 25. 5 here, 2 remainder. 5 times 2, 10. 10 plus 2, 12. Again 5 times 2 10, 10 plus 1 11. Final answer will be 1125. Multiplication part you have to do very carefully. You have to substitute the correct values and you have to keep on multiplying in the same pattern and get the values. Right? So try to pause the video and do the question and get the answers. Let me do more questions for you to keep on practicing. Well, now have a look on this one. X is equal to 1, y is equal to 7. Now we are going to substitute. Right. 3 is written here as it is because it's a number. But x, okay, we'll write it down. Y to the power 2 means how many y? Yes, 2 y's. 3 multiplied by x means now they have given it is 1. So we'll write down 1. Y means it is number 7. Again another y is there. Right. Now you have to know multiplication tables very clearly. 3 times 1, 3. Okay. 7 times 7, this multiplication mark I wrote here. 7 times 7, that is 49. Now what is 49 multiplied by 3? 3 times 9 is 27. 27 means last digit we write here, remainder we take it here. 3 times 4, 12. 12 plus 2, 14. Final answer will be 147. This is the way of substituting a given value for the algebraic base. So now you are able to do all your exercises in this lesson. So in this lesson, what is the summary I can tell you? You learn how to express an unknown term, multiplying repeatedly by something called powers. And there you have the base, you have the index. And you know how to substitute a given value for a base, unknown base. And you know how to expand index form, and you know how to write down the expanded numbers in index format. Right, these are the basics things in this lesson. So hope you have understood the lesson, and let's meet up with another video. Have a nice day.